Hello, 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 hello. Hello, everyone. Welcome to Gate Wallah. So, everyone, please join the class. Good evening, good evening, good evening. Everything is fine. ER villain. Okay, fine. एक बार इसको रिफ्रेश करो सन. Good afternoon, dear. Good afternoon. नीचे करो बस ठीक. Okay, audio video clear? Okay, fine, great. So, this is the target 2026 and we are going to discuss some important questions related that can be best possible way for this particular question series. Na? Okay, so coming to this one, this is for the English students. Na? For Hindi students, the questions will be totally different. That will be done at 7 p.m. Na? Today at the Gate Wallah ECE and IN channel. Na? Okay, fine. So coming to the question discussion, please see, we will see the questions in that way so that you can understand things, how to tackle the problems based on the especially for the Gate 2026. Na? This series motivation and the aim of this particular series is to whatever you have studied once go through all the chapters so that you can understand that you are able to solve the questions. Na? Are you getting point? This is not the motive of the series that you all feel demotivated or go into the depression if you can't solve any questions. Okay, so that this series motivation and motive is very clear, just to make you revise things. Already you have revised your concept, now you can practice with questions also so that you can understand that what we have discussed, that you can do it. Na? Okay, you are a student of ME, can I watch? Why you will watch this one? ठीक है, बैच प्रेजेंट हैं सर, मैक्स हिंदी वाले बच्चे ही प्रेजेंट हैं, तो हिंदी वाले बैच बच्चे ठीक है, इट्स अ क्वेश्चन डिस्कशन, so you can present, there is no problem in this one. Na? So coming to the first question, and we will start this discussion and you guys will solve this question. Na? Okay, so in this particular question I am asking about this particular current, na, I. What is the value of this current I? They have asked. Na? So how you can proceed this question? See this one. This is the current I that has been asked. Na? Now I have told you in the lectures also, when you see any question and they are asking about voltage and current, what should be your first approach? Na? The first approach always must be your inspection method. Na? Inspection method. Na? And what is the inspection method? Inspection method means just finding the current in each branch and then after making it KVL and KCL, and you can solve those questions very easily. Na? So in this particular question, how we can solve? Resistor is missing here. Resistor is missing here. Okay, let me check this one. Na? Resistor is missing here. This is 2, 4 and this one is equal to, let's take it 5 ohm. Na? Let's take it 5 ohm. Please take it 5 ohm. No problem. Take it 5 ohm. There is no problem. Okay. Now coming to the inspection method. Na? Now finding the current in each branch, our first priority. Na? With that, so that the variable must not increase by 2. Na? So I will make this a copy of this particular question. Then we will see. Na? You can see this is the current I that we know that. Na? Absolutely fine, sir. One more current we know that this is the 5 ampere. Na? Absolutely fine, sir. Now if you see clearly, what you can see, this is the 20 volt. Na? So from here to here you have a 20 volt. Na? Is it correct? Yes, sir. From here to here you have also 20 volt. Na? If this is 20 volt and this is 20 volt, what about this voltage? This voltage you will get it 0 volt. Na? Why? It is, if you do the KVL in this loop, minus plus 20 plus minus 20, this will 0. So this current will become 0 ampere. Na? Wow. If this current has become 0 ampere, this is I. So this current will also be equal to I. Na? Wow. It's too cool. Now, if it is 5 ampere, it is 0 ampere. So this current will also be 5 ampere. Now. So if somebody is asking 5 ohm KVL invalid ho jayega. No, never. How it can be invalid? How it can be invalid, Murkh? How it can be invalid? This is the current source. Na? How it can be invalid? How it can be invalid? What are you saying? Okay. This one is what? 5 ampere. Na? So now you have this one only variable, that is the I. Na? Can I apply the KVL in this particular loop? Yes, we can apply the KVL in this loop. So if you apply the KVL, this is the direction of this one. This will become plus, minus. So KVL, this is rise 20. This is minus plus rise, plus minus drop. So I into 4 is equal to how much? 10. So I into 4 is equal to 10 minus 20. So we have is equal to minus 10. So I is equal to, you have got it, minus 10 divided by what? 4. Na? This much of the ampere, that is the value of what? I. Na? How much you are getting? Negative you are getting 10 by what? 4. That is equal to minus 2.5. Na? This must be the correct answer for your this particular question. Minus 2.5 ampere is the right answer for this particular question. Minus 2.5 ampere. Na? Minus 2.5 ampere. Prakash, how you are solving, beta? At this stage, you are getting confused in KVL and KCL. How it can be invalid? 5 ohm. How you have said that this is going to be invalid? On what logic? On what funda? Okay, is it done? Minus it will be answer. Who have given the positive 2.5 answer? They are wrong, and definitely give a slap to your cheek. Na? Definitely. Because at this time, if you are doing such kind of mistake, that is the... How many of you have solved by yourself? Please tell me in this chat box. Okay. If somebody is asking in the same question, if somebody is asking, find the power absorbed by 20 volt. So can I find the P20 volt? Yes. P20 volt power will be 20 multiplied by what is the current is flowing? This is the I current. So I will get it 20 into I value is minus 2.5. So we have 20 into 20. You are getting 50 watt minus. Now, according to direction of the current, this is absorbing power. So this is absorbing power. Now, if examination is asking find the absorbed power, you will get what? Minus 50 as answer. If they were asking about the deliver power, you will get the answer of 50 watt na, in deliver. Na. If somebody is asking, then only. Na. Are you getting point? Similar way, you can calculate the power of this one also. This is equal to 100 watt. Na. Here you will get the 100 watt. Na. What? Absorb. Na. Positive absorb. Na. Absolutely fine. Here you can also calculate the power. Na. 10 into what? Minus 2.5, that is 25 watt, negative delivered, that means absorbing plus 25 watt. Na? So you can calculate whatever they are asking, never ever bother that I can't do it. Na? You can analyze the whole circuit completely without any doubt. Na? Is it okay? Absolutely okay, sir. Now coming to the next question, can you do this question? Please do by yourself this question. Na? This question, do by yourself. Na? Everyone, please do by yourself. Please note down and give me the answer for this particular question. And here, this is resistance simply R and this is the voltage V only. Na? There is no resistance given there. Na? Please do and tell me the answer. Everyone, please tell me the answer. They are asking about the find the power delivered by the 10 volt source. Na? Power delivered by this voltage source. Na? As well as power delivered by 1 ampere current. Na? Both you have to calculate. Na? So again, for finding the power, you need what? Voltage and current. Na? So if you want to calculate the power of this one, then you need the current in this particular circuit. Na? If you want to get the power of this source, then you need the voltage across it. Na? Voltage and current you have to find. So what I will do? I will go with the inspection method. Na? Again, na? Inspection method. Correct? So what is the inspection method? Finding the current in each and every branch. So what I will do? Let's start with this one. So it is given that this is 1 ampere. So this is 1 ampere. This is also 1 ampere. And it is given that there will be 0 ampere current in this one. So we have 0 ampere in this one. 0 ampere. If it is 0 ampere, this will be 0 volt. Perfect. If it is 0 ampere, this is 1. This will also be 1 ampere. This voltage will be plus minus this one. Now coming to this one. Do we know this current? No, we don't know. Do we know this current? No, we don't know. So we will assume one current. So I am taking this current as I1. This is I1. This current will also be I1. This is 0 ampere. So this current will also be I1. This will be plus minus like this one. And this will be plus minus also. Now we have how many variables are there? Only one variable. You need to figure out the value of I1. How we can do this thing? Now we will go with the KVL and KCL. So can I apply the KVL in this loop? Yes, we can apply the KVL in this loop. So KVL in loop 1, if we do, this is drop, this is rise, this is 0, this is rise. So rise is equal to 10 plus, that is equal to 1 into 4. And this one is the drop. Drop is how much? 20 into I1. So we have the value of I1 is equal to 14 divided by 20. This much of the ampere, that is equal to 14 by 20. 14 divided by 20, you are getting 0.7 ampere. This much of the I1 current you have got it. If 0.7 ampere you have got the I1 value, what about the power of P10 volt? P10 volt power will become, that is the 10 multiplied by I1 current. So 10 into 0.7, you will get 7 watt. Whether it is deliver absorb, according to the direction this power is delivered. This is delivered. So what power they have asked? Find the power delivered by 10 volt source. So this answer will be plus 7 watt. Done, done, done. One is over. Now coming to the next one. They have also asked about this current. Now you know that. I1. They have also asked about the power delivered by this one also. If you want to calculate the delivered power, can I assume the voltage polarity? I will take, let's take V1. Is it okay? We need to figure out the value of V1. Can I apply the KVL in this loop to get the value of V1? Yes, we can apply the KVL. So KVL in loop number 2, if you do, this is drop, this is drop, this is plus minus here, this is rise. So 6 into I1 is equal to V1 plus 18 multiplied by I1. Is it okay? Sorry, 6 into 1, 6 into 1, 6 into 1. So we have V1 is equal to 6 minus 18 multiplied by 0.7. So we have V1 is equal to 6 minus this one, 0.7 into 18, you are getting 12.6 minus 6, you are getting minus 6.6 volt. Now if we calculate the power of P1 ampere, P1 ampere power will be simply V1 multiplied by 1, and V1 value we have minus 6.6 into 1. So we have got minus 6.6 watt. What is this power? This is a delivered power according to our polarity. So this is delivered. So they have asked about the delivered power. So this answer will be minus 6.6 watt. And this answer will be plus ka 7 watt. Why we are getting negative current? Minus 2.5 in first equation. Why you are getting negative? Where I am getting minus? But this question has been already completed. Why you are getting negative current? Why you are not getting negative current? If you apply the KVL in this loop, this is volt rise, this is rise, this is drop. So 20 plus this one is equal to 10. So I value you will get 10 minus 20 negative. You can't do the basic algebraic summation and subtraction. And you are at the stage of writing the examination 26, dear. So how much answer will be? Anyone have got the answer? Nobody has got the answer. Only one student has given answer minus 6.6. So the answer will be only minus 6.6 watt and the 7 watt. Both answer will be correct answer. Na? Are you getting the point? Anyone who have solved by yourself and got the both the answer? Anyone in this particular class? Can you tell me? See, my English is not so good, na? So please answer whenever I ask something, na? Okay? Who have solved by yourself, not by seeing here, na? Okay? So shall we proceed with the next one? Okay, coming to the next question. Na? This is the next question. Na? I have taken 4 questions here. Na? There is not only one question. I will take all kind of questions, but it will be like that. Na? That we will take 3 to 4 questions in single question. Na? 3 to 4 questions. This here we have 4 questions. Na? Not only one question. This is called the analysis. Na? Now, I just want to that everybody please do by yourself. Na? I am giving you time. I am giving you at least 2-3 minutes time and at least find these 2 values first. Na? Please everyone do. If you have done, then I want to see whether you can do or not. Do. You have a whole opportunity. Who have told that I have done by myself? Na? Please do it. And get me the value of I and V1. Na? I and V1. This is V1. Na? This is V1. Okay. Please do. I am just waiting. I have given you approximately 2 minutes time. Na? Here we don't have the poll right now, but you can do. Na? I am just waiting. Please do and tell me the answer. V1 and I. Na? First find these 2 values. Na? I just want these 2 values. Examination may ask one value. Na? They can ask about the I, they can ask about the V1. They can ask about the P total delivered, they can ask about the P total dissipated in the circuit. I am still waiting. Tell me. Then I can believe na, whether you guys are doing by yourself or you are just waiting for just noting it down. This is equivalent to 3 to 4 question. I is equal to 5 ampere. One student has given answer. Second one is different answer. Minus 1.25. We have got 2 answers. Anyone else? You have 1 more minute time. Na? I am giving you time, sufficient time. Don't worry. Anyone else? Still waiting. You have 1 more minute, na? Still waiting. 2 students had given answer and both had different answers. One is giving 5, one is giving minus 1.25. I don't know which one is correct. I is 3 ampere. Third student have also given the answer, but 3 students have given answer and 3 individually are different answer. Na? Fourth one is given 3 ampere. Okay, let me start. Na? So, if you want to find the I, what I will do? I will go with the inspection method. Na? Inspection method. Okay. So, what I will do? See here, V1 is 6. Different answer we are getting. Na? Question is one, but answers are different. Na? So, I am making its copy. Na? So, I just made this copy. Now, you can see. In this one, we need inspection method. Na? We have already 2 variables, na? V1 and I. Na? If you look at this one, can I get the, if it is 2 ampere, can I say that this voltage will be equal to how much? It will be equal to 2 into 4, that is equal to 8 volt. Na? That's cool. If this one is the 8 volt, then this voltage is also 8 volt. Absolutely fine, sir. If it is 8 volt, then what about this current? This current will be 1 ampere. Na? 8 by 8, 1 ampere. If this is 2, this is 1. What about this current? 3 ampere. Na? If it is 3 ampere, this is also 3 ampere. Are you getting point? Yes, sir. Yes, sir. Now you tell me, can I take the parallel combination of this one so that it will become very easy circuit, and parallel combination of these two? If you do the parallel combination of this one, you will get 6 into 2 divided by 8. Then you are going to get it 12 divided by 6 into 2 divided by 8. You are going to get 1.5 ohm. Perfect. What is the parallel combination of this one? 10 into 2 divided by how much? 12. So 20 divided by 12, if you do, you will get 1.667. Is it okay? Absolutely okay, sir. Just see here. So can I replace this one with this resistance? I am doing here only. This is 1.5 ohm. And this one is equal to 1. How much? 667 ohm. There is, we have seen this resistance in place of this one. Can I just remove all these things? This will become more easy to understand. So I am removing this one. And for this one, I have replaced this circuit so that it will look like very nice. Okay. So this is more clear here. So we have this resistance. We have this resistance. Is it okay? 1.667 ohm. 1.5 ohm. Is it okay? Now this 3 ampere will go this side also. This side also 3 ampere. This is also 3 ampere now. 3 ampere now. Perfect, sir. Is it okay? Absolutely fine, sir. Now, if you clearly see, this will be plus minus. 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 Can I apply the KVL in this big loop? Yes, we can apply the KVL. If you do so, what I am going to get it? This is the minus plus rise. So 2 into I. Absolutely correct, sir. Minus plus rise. This is rise. This is rise. This is rise. This is rise. All are rise. So can I write down? This is 3 ampere multiplied by how much resistance? 1.5 plus 5 plus 1.667. Is it okay? And plus 8 volt. Perfect, sir. So 2I is equal to, you are going to get it, how much it will be? 1.667 plus 5 plus 1.5, you are getting 8.16 into 3 into 3. So I am getting 24.5 plus 8. So the I value is equal to, sorry, what I have written? Sorry. This will be positive. Everything is positive here, and this will be 0. Okay, fine. Now fine. Okay, this will be positive. Correct. This will be equal to 0. Everyone is no, something I have missed. Oh, sorry. Okay, these all are positive. This is drop, so equal to 30. Equal to 30. So I have write down here 30 also. So what is the value of I? 24.5 plus 8, that is equal to 32.5. So we have 30 minus 32.5 divided by 2. So how much you are getting? Minus 32.5 minus 30, you are getting 2.5 divided by 2. Divided by 2, you are going to get minus 1.25 ampere. So our answer will be minus 1.25 ampere is the correct answer for the value of what? I. You can apply the KVL in this loop, dear. This is rise, this is rise, this is rise, this is rise, this is rise. This will be drop. So we have this much of the equation, and we have got minus 1.25. Yes, absolutely correct, sir. Now we have got the value of I, so we have got 1.25 ampere. Very nice. I'm proud of all the students who have got this much of the answer. Very nice, beta. Hopefully 1 or 2 students have got this particular answer. Now coming to the voltage V1 now. So you can clearly see what is the V1. V1 is this voltage. So V1 can directly be written as 2 into I now. So 2 into I means 2 into minus 1.25 simply now. So we have the answer of V is equal to into 2. So we have minus 2.5 volt now. Done. Minus 2.5 volt now. Minus 255 volt. This is the V1 value now. Absolutely fine, sir. Now coming to the next part, that is the P total. If they are asking delivered, or they can ask P total absorbed, or they can ask P total consumed, then we will calculate the individual source power na. So we have the powers P V1 is equal to V1 multiplied by what? I will calculate the current na. And the next one is what? P 30 volt is equal to 30 into what? 30 into what? 3 na. You can see this is a source 30 into 3 na. So this is delivering current na. So we have 90 watt. This is delivering. Now coming to the next source, this is the source. We have the voltage, we don't have the current na. Can I get this particular current? Yes, we can get this particular current na. If this is I, this is 3. What about this current? This current will be equal to, this is incoming current, this is the incoming current, and this is the outgoing current na. So 3 minus I na. Is it okay? So V1 multiplied by 3 minus I. So we have V1 is minus 2.5 into 3 minus I value is equal to minus of 1.25. So minus minus plus 1.25. So we have the value of 2.5 into 3 plus 1.25. You have 4.25 into 2.5. You have the value of minus 10.625 watt. According to my direction of the current, this is absorbing. So I will take it as absorbing. So, or we can write down plus 10.625 watt delivered. There are two sources and both we have calculated the individual power. And this power is always equal to the positive delivered powers of the sources. This is positive delivered. Yes, sir. This is positive delivered. So just add it on. So it will come out to be 90 plus 10.625. So we have the answer plus 90. This is equal to 100.625 watt. This will be the answer. If exam is asking, this will be the answer. Now coming to the dissipated power. P total dissipated will be here directly equal to how much, dear? Directly equal to P total absorbed, that is 100.625 minus, is there any source present that is giving a positive absorbed power? No. So it will be 0. So simply 100.625 watt. Very nice, but I am really proud of all of you who have given the right answer here. 100.625. It's not 108. It will be simply 100.625. Okay. So Prakash, you have given the very nice answer, dear. So I have got very few answers, and out of them only 1 or 2 students have given all the answers are correct. So all answers we have got it. This is one of the beautiful question. Is it okay? So in such type of question you have to take care in examination also. Here we have done 4 questions. It's not 1 question. It's like a 4 question. Okay. So don't think that is 1 question. In my every question you can see that there are multiple questions. Okay. Please do. And then we will proceed with the next question. So this is the next question. I am going for the. Please solve this particular question. Everyone, please. Here examination may ask 3 questions. 1, 2, 3. I have taken the questions in this way. These are the 3 questions that examination will ask only 1 question. Whether they will ask VTH, whether they will ask IN, whether they will ask the RTH across what? AB terminal. Na? Please do find. I am giving you 2 minutes time in this one also. Na? Please find everyone. Please do find. I don't take number of questions. I take one questions and do proper analysis of those questions. This is my style of teaching. If you guys like or you don't like, I don't care. But I can't change my style of teaching because I know that what is beneficial for the student. Number of question is not beneficial for the student. One question and its deep analysis is important for the student. Devil is saying that 0 volt, okay. Please do. I have given 2 minutes time now. So please solve. Everyone. Prakash is saying 0, okay. Very good, beta. Very nice. So if you see this circuit, if somebody is asking here VTH or ISC, na, whatever, you can see clearly in this particular circuit, there is no independent source. Na? It is just a bluff. Na? So if there is no independent source, then definitely both answer will be 0. Na? 0 volt and this is 0 ampere. Na? Need not to calculate this one. Na? In examination, it has been asked sometimes na, that you don't have the, and students are solving such kind of question again and again. Na, okay. So this will be, both will be 0, 0. Na. Now coming to the RTH calculation, na, that is important. Na. So let's begin with the RTH and do solve and tell me the answer. RTH. Exactly. Yesterday I have discussed also na, that if you don't have the independent source, never ever solve. Na. Okay. Please do. Now do calculate the RTH. Na? Do calculate the RTH. Na? Students solve. I have seen that. Many students start solving, finding the VTH and RTH in this question. Na? VTH and ISC. Please solve for the RTH. Na? And give the answer. Everyone please. Varun, Prakash, Devil, Siddhant, Mehak, Gate 26. Everyone. RTH calculate and give me the answer. RTH, one is saying that SDV, Dipansh is saying that RTH is 1500. Very nice. Kevin Patel is saying that 500. So it will be only one value, na? Whether it will be 15, whether it will be 500 or whether something else. So please check it. I think in this particular live stream, maximum students are from Hindi. Please once you can make any chat here, who they are from the Hindi batches and who they are from the English batches. In my opinion, because I can remember these students. And name is also saying that, na? 1500, 300. Okay, 500. We have three kind of answers we have got it, na? 300, 500, 1500, na? Okay, 1500. Okay, let's do it, na? So we have the RTH calculation, na? I have told you, na, most of the students are from the Hindi batch, na? But this is happening in the English batch and very few students are from the English batches, na? They are not interested, I guess. Okay. So we will start with the, if we want to calculate the RTH from here, this is which kind of case? Case number 4, na dear? We have discussed yesterday in the Maharevision also. Okay. So tell me, if it is case number 4, so we will connect a 1 volt source here and we will calculate this particular capital I, na? Perfect, sir. And then RTH will be simply 1 by I, na? There is no independent source here. So now we will go with the inspection method. Na? If it is 1 volt, this will be also 1 volt. If it is 1 volt, what about the Ix current? This current will become 1 divided by 750. Is it okay? Absolutely okay, sir. If this current, you know that you can know this current also, 1.5 into what? 1 divided by 750. Perfect. This is also, you know that. Now we have this current, you have this current, you have this current. Can I get the current in this one also? Can I get the current in this one also? We know this voltage also now. 250 into what? 1 by 750. Wow, sir. It's very nice. Na? Absolutely fine, sir. Now, see this one. Okay. You have this voltage is equal to 1 volt, na dear? Yes, sir. This is 1 volt. Na? If it is 1 volt, this is 1 volt, 1 volt, everyone is 1 volt. And this voltage, now you know that. Na? What about this voltage? This voltage will be equal to this voltage minus this voltage minus 1. Na? So what I will write down? 250 divided by 750 minus 1. Na? So we have the voltage that is equal to 250 divided by 750. We have 0.33 minus 1. So we have the value of minus 0.666 volt. Na? Is it okay? We have this voltage. Na? If you have this voltage, then this current will be how much? This current will be equal to simply minus 0.666 divided by what? 500. Now we know all the current we can do. Abhi bhi evening mein. So dono, yes, evening there will be, but in that class questions will be different. Here question is different. Here their question will be different. So everyone must be there in the evening class also. Na? So what we have now, apply the KCL in this loop. Na? So we have incoming current I. This is also the incoming current. So plus minus 0.666 divided by 500. This is the incoming current. So plus 1.5 divided by 750. That's cool. Now coming to the next one, that is the outgoing current. So this is equal to how much? 1 by 750. Perfect, sir. So what is the value of I? I we have got it, that is equal to 1 by 750 minus 1.5 by 750. This is minus, it will become plus 0.666 divided by 500 now. Is it okay? So I value you will get it. I am doing now. I am going to do, this is minus 0.166 na? Okay. Divided by what? 500 na? So we have 1.33 into this one. Now coming to the plus 1 divided by how much? 750 na? So we have this value is equal to na, and then I have to do the plus of, sorry, what I am doing? No, 1 divided by 750 plus 0.666 divided by 500. We will get this one, and minus 1.5 divided by 750 na. So we have the value of 6.665 into 10 to the power minus 4 na. So the RTH value you are going to get it 1 divided by I. Can I do the reverse of this one? So I am taking inverse. So we are getting 1500 ohm na. This is the right answer for this particular question. RTH is equal to 1500 ohm will be the correct answer now. So we have done this, we have done this, we have done this thing now. Okay. Are you getting my point? Absolutely getting a point, sir. Now this is done, done. Now coming to the next one now. Please do check this particular question. No problem, dear. It's a 1500 RTH now. Yes, 1500 ohms sahi hai. Yes, absolutely. Now, please do this particular question. Here also, we will calculate 5 questions in this particular circuit. Now 1, 2, 3, 4 and 5 now. So that we can at least recall everything now. That's why I am doing this thing now, analyzing these 3 now. In examination for this particular circuit, they can ask such kind of questions now. Here we have the RL value now. Please draw the circuit. And what I am asking, please do calculate first one now. First I am asking, find the RTH value now. First everyone please do RTH calculation now. First everyone do RTH calculation now. That is the first thing you have to do. RTH you can do easily. First everyone do the RTH calculation now. So if you do the RTH calculation, so what I will do for RTH calculation, I am doing the first one now. So for RTH calculation, you know that which case this belong. This is the RTH calculation from here. So this is a case number 2 problem now. If it is case 2 problem, then what I have to do? Independent current source will be replaced by open, independent voltage source will be replaced by short. Na? Perfect. So we have, this is shorted, this is open. Na? Absolutely, sir. So just do this thing. This is shorted, this is open. Na? Perfect. Now you have to do the calculations. Na? That is important to us. This one is correct? Yes, sir. So you can see clearly these 2 are in parallel. Na? These 2 are in parallel. Can I take this parallel? If you see this one, these 2 are in parallel. Na? Yes, sir. This is equal to parallel. Na? See very carefully, you can do mistakes. Na? 25 into 5 divided by 30. Na? Absolutely fine, sir. Is it okay? Absolutely okay, sir. Now you can see, can I make this circuit, if it is parallel, can I make this circuit like this one? If you see, I have this one and there is a resistance here. And here we have a parallel resistance like this one. Like this one. This is the circuit, you can see clearly. Na? And this is the AB terminal. Like this one. Na? Is there any role of this resistance? There is no role. No? So this resistance will be neglected. Na? You have 20 ohm. You have this 10 ohm. Is it okay? Now tell me, this is 60. Na? This is 60 ohm. Na? So because it is open, so there is no use of this one. So we have these 2 resistance will be in series. Na? So we have 30 ohm. Na? So we have 60 ohm. And we have the 30 ohm. Na? This is 60 ohm and this is 30 ohm. Na? Now just make it parallel. So RT will come out to be 60 into 30 divided by how much? Divided by how much? 60 into 30 divided by 90. Na? So 0, 0 cancel. This is 3, 20 ohm. Na? So 20 ohm must be the right answer for the RTH. Na? 5 और 25 series में. 5 and 25 series. No dear, it's in parallel. Who said that it's series? Why it is in series? If it is A terminal, if it is B terminal. So B, na? A to B, this will be in parallel. Na? Why it will be in series? It's not in series. Okay. Getting into NIT. 50 plus is a good marks for NITs. No? 20 ohm will be the correct answer for this particular question. Okay, Varun? How it can be series, dear? You mark the polarity. Na? This is the A terminal, let's take A. This is the B terminal, this is B. This is also B. A to B, it will be in parallel. Na? Are you getting point? And what is the use of these 2? Na? There is no use of this one. Na? Because it will be neglected simply. Na? Okay, great. Now coming to the next one. If somebody is asking in the same question, find the VTH. Na? Everyone please do calculation, find the VTH. Varun, have you got the point or not? Or is still confused? Everyone please do calculation na, plus VTH na. Everyone do calculation and tell me the VTH value na. Tell me the VTH value na. First question we have done it, and now it's the next question. Find the VTH, everyone. I am starting solving, you match your answers, na? Okay? But you have to do by yourself. Na? So, it is asking about VTH calculation. What I will do? I will go with the inspection method. Na? Inspection method. What variables we have? Right now we have only VTH. Na? So, if you see clearly, this current will be 0 ampere. Na? Perfect. This is VTH. So, this will be also VTH. Na? Perfect, sir. Is there any problem? No problem, sir. Now, right now we have only one variable, na, VTH. Na. So, you can see this is 1.8. Can I get this current? Yes, VTH by 16. Na. Is it okay? Absolutely fine, sir. If this current, this one, this current, this one, can I take this current? This current will come out to be 1.8 minus VTH by 16. Is it okay? Still we have one variable. We have whole opportunity to make it two variable. Na? So, here also you can say it is 0. So, this will be also 0 ampere. So, the same current will go this side also. Na? This current will also VTH by what? 16. Is it okay? Absolutely fine, sir. Done, done, done. Absolutely done, 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 sir. So, tell me, this current we have got it. Now, we have only one variable right now. Na? So, can I take this current, we know that. Can I make this current also? We don't have the current of this side. So, I am taking it as a I1. Na? Is it okay? If I am taking I1, so tell me, what about this current? This current will become I1 minus 1.8. Na? Okay? Absolutely fine, sir. Now, we have done it. Na? All the branch current, and we have two variables. Na? So, we need two equations. Na? We need two equations. Na? So, coming to the first one. Na? If you see clearly, can I apply the KVL in this loop? See. Can I apply the KVL in this loop? If you apply the KVL in this loop, you will get VTH in single shot. Na? You have to think na, properly. Why you will get VTH in single shot? Because this is 9 volt. This will come into in terms of VTH. This will come into in terms of VTH. This will come into in terms of VTH. So, you will get VTH directly. You don't need these currents and all. Na? Correct? You have to think like this one. Na? So, if I am doing this particular loop, so we have KVL. So, this is 9 volt voltarized. This will be plus minus. This is also voltarized. This is drop. Na? So, we have plus 20 multiplied by DR 1.8 minus VTH by what? That is equal to 16. This is rise, this is drop VTH, and next one, this is also drop plus VTH by 60 multiplied by 10. So, how much VTH it will be? 9 plus 20 into 1.8 minus 20 by, this is equal VTH by what? 3 is equal to VTH plus VTH by what? 6 now. So, VTH take it one side, VTH we have now 1 plus 1 by 6 plus 1 by 3 na? And that is equal to how much it will be? 9 plus 20, 20 into 1.8, you will get 36 plus 9, you are getting 45 na? So, 45 na? Take it 6 as LCM. So, VTH we have into 6 plus 1 plus 2, that is equal to 45 into 6. Na? So, finally, VTH we have, that is equal to 45 into 6. You have 270 divided by, this is equal to 6 plus 7, 7 to 9. Na? That is equal to 30 volt. Na? So, if you have got the 30 volt, that is the correct answer. If you have got some different answer, that is wrong answer. Na? So VTH will be only 30 volt. Na? This is right answer. Only one student I can see who have given the absolutely right answer, that is the Prakash. Now Prakash, you are doing very nice beta. If you keep on doing like this one, I am definitely damn sure you can do better, very nice in the examination. Na? Okay. Sanyukta also given the answer 30 volt. Kevin Patel. Kevin Patel, how is going studied here? 30 volt. Na? 30 volt. 30 volt is the right answer for this one. Na? Who have done by yourself, that is very nice. Who have got the 33 point, that is wrong. How you are doing, Varun? Why every time you are doing the mistake? 30 volt is the correct answer. Na? Is it okay? Absolutely fine. Very nice beta, very nice. So coming to the, if somebody, let's say examination doesn't ask about this one and doesn't ask about this one. Na? They have asked about IN. Na? Don't try like this one, na? That we know the VTH, we know the RTH, I will get the ISC. Na? If you do like this one, definitely it will be very hurtful. Na? I am saying that if examination only asking IN, then you have this value. No, you don't have this value. You don't have this value. Na? Then you have to calculate the IN value. Na? So IN value, do by yourself. Na? Do by yourself. Do by yourself. Na? Okay, IN value at least do by yourself. Na? Okay, how much you will get it, you can match the answer. That's why I have given the this one as a homework. Na? Do by yourself. Na? Answer, you know that. Na? It must come out to be 30 divided by what is RTH, you have got it. Na? This has to come out this one. Na? That is called 20. 30 by 20. It has to come out. Na? 1.5 ampere. Now, if the question is asking condition for the MPTT, so MPTT, there is a RL here. Na? There was the RL here. So RL must be equal to RTH. Na? RL must be equal to RTH. Na? If question is asking condition for MPTT, you have the RL value at the AB terminal. So we have RL must be equal to RTH. Na? And RTH, we know that how to calculate. This is 20 ohm. Na? So next answer will be simply 20 ohm. Na? If they are asking about the maximum power, PL max, you know that PL max, for PL max you need VTH square divided by 4 RTH. Na? So VTH, we know that. Na? This is coming 30 square divided by 4 into what? 20. Na? So you can get the value of PL max also. Na? So 30 square divided by 44 into 20. Na? So we have 11.25 watt. Na? Is it okay? So 5 or 6 variety of questions they will ask and you can do very well. Na? Are you getting my point? Yes, sir. Absolutely getting a point, sir. Now coming to the next question. This is variable, na, by default. Please do. Please do calculate these questions. Na? They are asking about RTH, VTH and RL max power. Na? 3 kind of questions they can ask. Na? So at least everyone find all 3 answers. Na? First of all, do calculate the RTH value and tell me the answer. I have given you time. Please do. VTH 20. Okay. VTH you are getting 20. So, if we start solving, finding the RTH value, na? So first we will start with the RTH calculation. If they are asking about RTH calculation, then we will go with the proper approach. So tell me how we can solve. So we have, just remove this one. We are RTH calculation. So here we need RTH. Can you tell me which kind of circuit is this one? If we want to calculate the RTH here, this is a case number 3. Na? If it is a case number 3, we will go with the test voltage approach, na? Plus minus 1 volt, and this will become the capital I. Na? And all other independent voltage sources will be replaced by short. Na? So just replace these sources. Na? This is also replaced, na dear? Okay, fine. So we have, this is shorted now. Now we need this circuit and we need to calculate the capital I value. Na? Now coming to this one, if you want to, we will go with the inspection simply. Na? If you see clearly, we have two variables, na? I and V naught. Na? If you see this one, what is happening? This particular current is how much? This current is equal to V naught divided by 3. Na? Perfect. This current we know that? Yes, sir. This current we know that, capital I. Na? So we have the one expression we have incoming current, incoming current, incoming. So I plus V naught by 3 plus 2 V naught. Na? This is 0. Na? So I value is equal to simply equal to minus V naught by 3 plus, minus 2 V naught. That means what? I is equal to simply V naught into minus 1 by 3 minus 2. Na? Perfect. We need one more expression. Na? We need one more expression. Na? Can I apply the KVL in this loop? Yes, we can apply the KVL. So if you do the KVL, we have the value of, this is plus minus what? Sorry. Just make it in a simple way. Na? So can I take the 3 as LCM? I is equal to 3 as LCM I am taking. Na? So V naught divided by 3 minus 1 minus 6. Na? Is it okay? So 3I, this is equal to minus plus, it will become 6 plus 1, 7. V naught is equal to 0. Na? Now it is cool. Na? Okay. First expression. Second expression will be V naught drop. This will be minus plus. This is rise. This is drop. So plus 1 is equal to I into 5. Na? Perfect, sir. So we have the value of V naught is equal to simply 5 by minus 1. Na? Just put this value here. Na? So we have 3I plus 7 into, this is 5 by minus 1 is equal to 0. So we have 3I plus 35 na? Minus 7 is equal to 0. So this is equal to 38I is equal to 7. So I value will come out to be 7 by 38. Na? I value is equal to how much beta? 7 by 38. Na? So what is the RTH value? So RTH we will get it 1 by I. Na? So we have the value of 38 by 7. Na? So RTH you are going to get it 38 by 7. Na? You guys are getting something different. 38 by 7. Na? I am getting 5.42. Is this wrong or something else? Or I have done some mistake? I am getting RT is this one. Na? Can you check it? 0.21. So where I have done mistake? This is 1 volt I have taken, that is cool. This is I, okay, fine. This is 2 V0, this is V0 by 3. This is V0 by 3, this is I. Na? So tell me, if I am taking the KCL here, this is incoming, this is incoming, this is incoming. So I have taken I plus V0 by 3 plus how much? 2 V0 is equal to 0. Now coming to this one, I is equal to, we will get minus V0, this minus 2 V0. I have taken V0 common, okay, fine, no problem. I have taken simply the 3 LCM. So 3 will go this side, 6 and 7. So I think this is right. I think this is right, na? 5.42, and everyone, they were, I don't know how they are getting 0.287 RTS, na? Okay. So we have the right answer of 5.42, na? Okay. Now coming to the next one, na? So you all have done the wrongly, na? Now if somebody is asking find the VTH, na? If somebody is asking find the VTH. So what is the VTH you will get? You make the VTH value calculation, na? So just make it open, then only you can do the VTH calculation. So I have just made it open. Na? So this will be plus minus what? VTH. Na? Perfect. Na? If it is VTH, now it will be 0 ampere. Na? If it is 0, this will be 0 volt. Then this VTH will be directly equal to this. Na? Can I apply the KVL here? Yes, we can apply the KVL. If you do so, sorry, there is no need of KVL. What I will get from this one KVL? Okay, need not. Okay, this is 0. So this current is equal to, V0 by 3. And this current is equal to 2 V0. Na? And this is 0. Na? If you do the KCL here, V0 by 3 is the incoming current plus 2 V0 is equal to 0. So we have got V0 is equal to simply 0 volt. Na? Is it okay? Absolutely okay. V0 simply is equal to 0 volt. Now, if V0 is 0, what is the VTH? VTH will be directly equal to 20 volt. Now, hence VTH is equal to 20 volt. Now, so VTH will come out to be 20 volt. Now, this is 5.42. This is 20 volt. Now, they have asked about the RL max power condition. Now. So, RL must be equal to how much? RTH. Now, simply. And now you have the VTH value, you have the RTH value, you can get the maximum power also in the circuit. Now. It is okay. Hopefully it is right. Na? So you can get the condition of maximum power also, you can get the maximum power also. So we have done 3 types of question in this particular circuit. Na? Okay. Almost if you see that we have solved approximately, I think 15 to 16 question, because in every question we are doing 3 to 4 questions. Na? Coming to the next question. See, it is written already here. Na? Very nice. Please, one by one we will find out. Na? Okay. In examination, they can ask 2 things. Na? One is what? One they can ask about the V0. One they can ask about this current I of t. Na? These 2 are the popular question that they can ask. Na? Okay. They can ask at t is equal to 0 plus condition V0 0 plus. They can ask about the di by dt at t is equal to 0 plus, and they can ask separately as a time constant. Na? These kind of questions they can ask with the different circuits. Na? That's why I have written all these things. Na? So tell me, we will do this question so that we can recall everything. Na? Time constant calculation, di by dt calculation, everything you can recall with the one question. Na? Okay. So, first of all, everyone please tell me, it is a first order circuit, so we can write down I of t also. Na? How? I steady state, I 0 plus, I steady state e to the power minus t by tau. Na? Perfect, sir. Now, if examination asking V naught t first, V naught T, they have asked first. Na? They don't ask all these things. Na? Then you have to apply this thing. Na? And for this calculation, what you need? What you need, dear? You need, okay, you need all these values. Na? Now, see carefully. I am not doing much more things. Na? You just see here very carefully. You have this kind of circuit. Na? You can see clearly here. If I will make properly, this is the A position. Na? And this is the B position. Na? This is the hanger. Na? So, if you see for T less than 0, this switch is connected to A number, and for T greater than 0, switch is connected to B number. Na? Once look very carefully, if this hook is moved to B number, this whole circuit will become independent source free. Na? There will be no source in the circuit. Na? Please tell me everyone, have you got it? So, if you are going to calculate this infinity condition in this particular circuit, whether voltage or whether current, there will be no source in the circuit. Na? If there will be no source in the circuit, it is going to be 0 ampere, because I have told you, na, if in the circuit there is no independent source, that means it is simply 0. Na? So, this will be 0 ampere, this will be also 0 volt, and this will be also 0 volt. Na? Are you getting my point what I am trying to say? It is, these are the things how you have to solve things. Na? Okay. Finally, na, very nice. Na? Now, one thing we have done, na, at least we have found V at a steady state in one go. Na? We don't need any calculation for that one. Na? Now, coming to the time constant calculation. Na? If somebody is asking time constant, we can directly calculate the time constant also. How? See here. For time constant calculation, what you need after switching circuit. Na? So, I will remove these here from here. Okay. And after switching, if you see, we have this kind of circuit. Na? For time constant, if I am doing, na? This will be connected to B number. This is the circuit we have. Na? If I will take this terminal as a P and this terminal as a Q, the time constant will be equal to L equivalent divided by what? R equivalent, na dear? Yes, sir. If you want to calculate the R equivalent here, this is the case number 1 problem. And case 1, how we will solve? By series and parallel operation. Na? If you check it, this is open. So, these two will be in series, 16 ohm. This is 4 ohm. And this 16 and 4 will be in parallel. So, RTH or R equivalent will come out to be 16 into 4 divided by 20. So, we have 16 by 5. Na? So, we have 16 divided by 3.2. Na? Now, if you do the L equivalent, how much L equivalent? 0.32. Na? Divided by 3.2. So, what we have? This is taking the inverse into 0.32. You have the value of 0.1. 0.1, or we can say 1 by 10 second time constant. You have got the time constant also. Are you getting point? Yes, sir. Absolutely getting a point. Now we need what? 0 minus condition. Now coming to the 0 minus condition. So if examination asks in this thing, you can calculate easily. If they were asking about the steady state condition, you can calculate that thing also. Now coming to the 0 minus condition. So if we go to the 0 minus condition, what we have? So I am going for the 0 minus condition. So for 0 minus condition, the switch is at position number 1. The switch is at position number 1. So I am doing for the 0 minus condition. So what I will do? The switch is at position number A, and this will be short circuited. At 0 minus condition, what we need? We need only capacitor voltage and inductor current. That's it. We don't need any other thing. So this is the inductor shorted. This current we need desperately, because here only we have inductor. We don't need all these V naught and all. We need only inductor and capacitor things. So we have this kind of circuit. If you see, if this is shorted, this voltage will become 0 volt. So this current will become 0 ampere. Absolutely fine, sir. So you can see This current is equal to 6.4 ampere. Now you can see if this resistance there is no role, so these two will be in parallel, so we can do the current division rule. This current will also be I0 minus. So I0 minus we can get it directly. 6.4 is the total current into 10 divided by how much? 6 plus 10. So we have the value of 6.4 into 10, we have divided by 16. So we have 4 ampere. And we know that this is inductor current. This is inductor current. So we have got this I0 minus. सर बीच में एक बार हिंदी भी बोल दीजिए. अब बोल तो दिया अमित कुमार. अब भैया अंग्रेजी चैनल है तो अंग्रेजी में ही बात करेंगे ना. ठीक है. 4 ampere will be the I0 minus. Now coming to the 0 minus we have got. Now we can calculate all these things at 0 plus. So we'll go with the 0 plus circuit. So what I will do? I will make the circuit for 0 plus condition. So what I am doing? I am going to make 0 plus condition circuits. So if I will make the 0 plus condition circuit, what we need? We need the 0 minus things. So I am going to do 0 plus condition. Okay. लेने के देने पड़ जाएंगे. चलिए. Okay, fine बेटा. So at t is equal to 0 plus, this switch will come out to be B number position. Perfect, sir. Just remove all these things. This will be replaced by current source. So we have the circuit look like this one. At t is equal to 0 plus, you know that the switch will become at this, and this is A. This will called as V naught 0 plus. This will be replaced by current source. How much it will be? 4 ampere. And across this the voltage will be inductor voltage VL at 0 plus. Everything will be calculated as 0 plus. ठीक है. वर्बल एप्टीट्यूड भी इंप्रूव हो रही है. अच्छा, लेकिन हमारे अंग्रेजी उस लेवल के है नहीं कि आपका वर्बल ठीक हो सके. बर्बाद और हो जाएगा आपके वर्बल. Okay, fine. So in this circuit you can see we have these two in series, and this is the resistance. Can I make this circuit as simple as this one? This is now 16. Sorry. Can I make this circuit like this one if there is no problem in this one? No, we don't have any problem. We have this current and we have this resistance. Is it okay? Absolutely okay, sir. This is 4 ohm. This one is equal to 6 ohm. This is equal to 10 ohm. Correct? If we have the 4 ampere in this direction, can I get this current? Can I get this current, beta? Yes, we can get it. Let's take this current is equal to, let's take some I1 current. So we have the I1 current at 0 plus condition. We have current division rule. So 4 into 4 divided by 16 plus 4, 20. That is equal to how much? 16 by 20. Absolutely fine, sir. 16 by 20. 16 divided by 20, you have got 0.8 ampere. Now tell me. If I want this voltage VL 0 plus, can you get it? These two are in series. Yes, sir. So from here to here, we have the voltage of what? VL 0 plus. If somebody is asking, then you can get it. This voltage 10 plus 6, 16 into I1. 16 into I1, but this polarity and this polarity are different. So minus. So I will write down 16 into 0.8. So we have the value of into 16. We will get it minus 12.8 volt. Now, if somebody is asking, find this voltage, then how you can find this voltage? You tell me this current I1 is going into 10 and this one. So can I write down I1 here? Yes, I1 will be here also. Correct? They need this voltage. So this voltage will be, if I1 is going this direction, this plus minus will be 10 into I1 and this polarity will become minus of this one. So V naught 0 plus, if someone asking, negative of 10 into I1. So we have minus 10 into 0.8, we have minus 8 volt. Perfect. So at 0 plus, if someone is asking all these things, you can calculate very much. Na? Sir, can't we take R equivalent in this circuit? We have taken the R equivalent here. If you take the R equivalent, you need these voltages. Now, how you will calculate these voltages? If you do the R equivalent, why I will take the R equivalent here? I will make the current division. Na? Okay. You need internal voltages, not here. Internal voltages we need. Na? So, why I will take the R equivalent and all things. Na? Okay. If you take the R equivalent also, you will going to get the same answers. Na? Okay. Now, finally, we got all the answers. So, can I write down, if someone is asking I of t, so I of t will be 0 plus initial current, we have got it. Initial current we have already calculated 4 ampere. Na? So, it is going to be 4 ampere. Na? 4 minus 0 e to the power minus t by tau. Tau is equal to 10t simply. Na? I will write down 10t only. Na? So, we have the answer of 4 e to the power minus 10t. This is the current answer. Na? Now, if someone asking V naught t, so we have 0 plus minus 8 minus 0 e to the power minus 10t. So, we have the answer of minus 8 e to the power minus 10t. Na? Because at 0 plus we have just calculated minus 8 volt. Na? Is it okay or not? Absolutely okay, sir. Now, if someone is asking di of t by dt at t is equal to 0 plus, I have already explained all these things. This will be equal to VL 0 plus divided by L. Na? VL 0 plus what we have? VL 0 plus will be equal to minus 12.8. Na? Minus 12.8 divided by L. L is equal to 0.32. Na? 0.32. Na? L value is equal to 0.32. Na? 0.32. Na? So, what we have? We have the value of negative divided by 0.32. So, we have 40 ampere per second. Na? So, all kind of answer we can do very easily. Na? All kind of answer we can do very easily. Na? There will be no issue in such kind of circuits. Na? If it is good, please tell me, everyone. So, I have included maximum things in this particular question. Na? Have you enjoyed? I have included everything in this one. Na? I have explained you how to get the transient equation. I have explained you how to get the time constant. I have explained you rate of change if someone is asking how you can do that thing. I have explained you at the 0 minus and 0 plus conditions how you have to do things. Everything is all about just a chapter number 1. That's it. If you know that thing, there will be no problem. If you don't know that thing, there will be extreme problem. This is u of t, 6 u of minus t. This is 12 u of t now. Okay. Please note down. Please do. This is u of minus t, this is u of t. Na? Okay. We will do one or two questions more. Then we will, you all will be present in that one also. Na? In that one. There we will do the questions on resonance also, and also power and AC circuit and 2-port also. Now, here I will not do the 2-port and all questions. Na? Okay. Because all the students are from that channel, I guess, in my opinion. All are from that channel, so why we are doing in separate? But you have got the advantage. What advantage? In this one, you have got all the questions. in the next what will be done on the Hindi channel, that will be different questions. So you will get advantage of getting more questions, na? Okay. Have you got the answer in this one? You have to find the dVc by dt. You need this one, na? So I have told you, na, for a capacitor, if you want dVc by dt, that means you need the IC divided by C, na? You need this one, na? Because IC is equal to what? dVc by C, C dVc by dt, na? If they are asking at t is equal to 0, so I will take it 0 plus. So you have to calculate the IC current, na? You need the IC 0 plus current, ना? ठीक है, ज्यादा क्वेश्चन मिलेगा. अच्छा मान लो हम दोनों में सेम ही क्वेश्चन करा दिए होते तो फिर वो जैसे बोल रहा गेट 2026, फिर तो वो जैसे एक ठो मेम चलता है ना, ये तो लेने के देने पड़ गए भाई. मान लो हम एक ही शीट यहाँ पे भी करा देते, वहां पे भी करा देते, तो क्या होता? ये तो लेने के देने पड़ जाते. तो ऐसा करते हैं. ठीक है, मतलब टीचर भी क्या करे बेचारा, टीचर कहेगा कि भाई 20 इतने क्वेश्चन इसमें करा दिए, यही क्वेश्चन चलो उनको करा दे, यहाँ तो अलग बच्चे हैं, वहां अलग बच्चे हैं, तो ये भी तो हो सकता है ना. ठीक है, चलिए. Okay beta, so we need to calculate what? This current, na? This is IC, na? Okay, स्किप कर देते. ये अच्छा इसने बोला, हम स्किप कर देते सर, हम क्यों अपना लेने देने पड़वाएं. चलिए, अच्छा ये बताइए इसका मीनिंग क्या होता है 6u of minus t. इसका मतलब होता है सिंपली दिस इज 6 एंड दिस इज दिस वन, ना. इसका मतलब क्या होता है? इसका मतलब होता है कोई वोल्टेज है जो कि t ग्रेटर देन 0 के बाद एग्जिस्ट कर रहा है, ना, 12 वोल्ट, ना. मतलब तो यही होता है. ठीक है, लेकिन हम बताते ही नहीं तो नहीं. लाप्लास क्यों करेंगे? वाई आई विल गो विद द लाप्लास, ना, आई विल नॉट गो विद द लाप्लास, ना. ठीक है, इज इट ओके? Now I have told you yesterday in the Maha revision also, I have told you whenever someone is asking t is equal to 0 या 0 plus या 0 minus या steady state, the calculation of 0 plus steady state, everything will remain same as you are doing for the first order circuit, na. I have told you this thing yesterday in the Maha revision also. Okay, so first to get the value of 0 plus we need 0 minus first always, na, always. Okay, so first what we will do for the 0 minus, na, and at 0 minus what things you need to calculate? We need only capacitor and inductor things, na. That's it. Capacitor voltage or inductor current, na. So tell me, if I am making it for the 0 minus, at 0 minus this voltage you are seeing that it's a 6 volt, but this voltage is a 0 volt, na. Is it okay? This voltage 0, na. So, and this capacitor will be open circuited, na, at 0 minus, na. So I will write down at t is equal to 0 minus, C will be open circuited, na. So this will become 0 minus, na. Okay, this will be 0 volt, this is 6 volt. Now you can see here 0 minus you have 6 volt, you have 0 volt 12 volt, na. This is 0, na. Now tell me what is the value of this? This will be 0 ampere, so this will be 0 volt. So this voltage and this voltage will remain same, na. VC 0 minus. Are you getting point? And you can see clearly if this is 0 ampere current, so this current and this current will be same series. Can apply the voltage division rule directly. So VC 0 minus you have 6 into 2 divided by what? 2 plus 1, 3, na? 4 volt, na? Is it correct, dear? Yes, sir. So we have got 4 volt VC 0 minus, na? And we know that VC 0 minus and VC 0 plus will always be equal. So we have that is equal to 4 volt, na? Perfect, na? Done, done, done. If it is 4 volt you have got it, now we will go for the 0 plus condition, na, where they are asking, na. So we'll go for the plus condition. So what I will do, at t is equal to 0 plus condition, at t is equal to 0 plus condition, what I will do, see here, this capacitor will replaced by, this will become now 12 volt na, and this will become 0 now. Na. Why it is 0? Because 6 volt is not applicable for t greater than 0. Na. So this will become short, this will become 12 volt, and here now we have a voltage source that is equal to 4 volt. Na. And you need this current, na. You need this current. Na. This is IC at t is equal to 0 plus. Na. Capacitor will be replaced by, capacitor will be replaced by what? Voltage source. Na. Now you have this particular circuit. Na. Now you have to solve this particular circuit. You tell me, you have two options. You have this current IC, you don't know this current, you don't know this current. Can I take one current? I am taking it this as a I1 current. Now, if it is I1 current, this current will become I1 minus IC. Now we have two variables, you can solve for it. Now. So can I apply the KVL, 1 KVL? This will become plus minus, this will become plus minus. Now. So 1 KVL we can do this big loop. Do it. Drop, drop, drop. Na. So what I will write down, KVL, we have 1 into I1 plus 4 plus 4IC is equal to 0. Na. So we have 4IC plus I1 is equal to minus 4. Now this is the first expression we have got it. Na. We need IC. Na. Now can I apply the KVL in this loop? Yes, we can apply the KVL in this loop. If you do so, so KVL in number 2, this is plus minus, this is plus minus, this is plus minus. So 12 plus 2 into I1 minus IC, and this is also plus I1 is equal to 0. Now. So we have 2I1, 3I1 minus 2IC. This will go this side, minus 12. Na? So we have next expression also. Na? Can I solve these two? Yes, we can solve. So 4IC plus I1 is equal to minus 4. You have minus 2IC plus what? 3I1 is equal to how much beta? Minus 12. Na? Is it okay? Absolutely okay. So we have this one. We need IC, na? Remove this I1. Na? If you want to remove, just multiply with the 3 here. Na? If you multiply with 3 and subtract it, you will get it IC bracket 12. We are subtracting, na? 12 plus 2. Na? 12 plus 2 you will get it. Na? Perfect. Equal to, this is minus 13. Minus, you are subtracting, na? So it will become plus. This is 12. Na? Sorry. 4 into 3, it will be 12. Na? Are you getting point? So this will become 0. Na? So IC at 0 plus you are getting 0 ampere. Na? Okay. So you are getting 0 ampere simply. So if it is 0 ampere, then dVc by dt at 0 plus is equal to IC 0 plus by C. So you have 0. So 0 volt per second. Done. The answer will be 0. Answer will be 0, dear. 0, 0, 0. 0. dV by dt answer will become 0 simply, because IC 0 plus you are getting 0 ampere. Check it properly and please confirm me then. Everyone please check it. I am getting 0. So answer will be 0 only. Answer will be simply 0 only. Na? Is it okay? Okay. So hopefully now the AC circuit questions and extra some questions we will do in that particular. 0.75 is wrong, beta. No, 0. Siddhant, you check it properly. Na? You check it properly. You check it properly. 0.75 is not a correct answer. Okay, dear? Okay, fine na. So AC circuit 2-port network questions and also the questions based on all these things we will do in the Abhyas session. So everyone must be present there na. Here it will be more than sufficient because all the students are from that particular, I know that there is no difference in this channel and that channel also na. Okay, so everyone be there, hashtag give me a promise. So we will do next level things in that particular session also na. It will be 0 dear, please check it. I can guarantee you it is 0 ना. आप कहां से हैं? मैं आई वॉज अंग्रेजी बोलना हिंदी में, ठीक है. आई एम फ्रॉम प्रतापगढ़. इट्स अ डिस्ट्रिक्ट ऑफ उत्तर प्रदेश नियर टू इलाहाबाद, प्रयागराज. ओके, हाँ इसीलिए बोल रहे हैं हिंदी वालों को, ठीक है. हाँ हाँ, एसी वाले को ज्यादा प्रायोरिटी रखेंगे, एसी को ज्यादा प्रायोरिटी रखेंगे. सर टेक्निकल इशू सॉल्व हो गया. आई डोंट हैव एनी टेक्निकल इशू राइट नाउ डियर. टाइम फॉर नेक्स्ट सेशन 7 PM बेटा, 7 PM, बट एट द गेट ECE CS चैनल ना, हिंदी चैनल. ओके, so I think that will be the good one na. So I have solved. Now you tell me how many questions we have done. Don't tell me like that na, 1 2 3. I have solved in every question. I have taken approximately 3-4 questions. In every questions I have taken such kind of things na. AC transient both sir. Yes definitely dear, definitely. Okay, so we are closing this session. We will meet in the 7 PM session na, in the Abhyas session na. And there we will do AC circuits and 2-port questions also, so that you can understand clearly na. Okay, thank you. Yes dear, हाँ मास्टर, yes बेटा, yes बेटा. मैंने बताया था ना 27 के जो बच्चे होंगे उनकी क्लास कैंसिल कल भी रही होगी, आज भी रही होगी ना. बिकॉज बेटा 26 की चीजें जब तक चलेंगी थोड़ा सा आपको पेशेंस रखना पड़ेगा ना. ओके, हाँ. ओके डियर, बाय बाय.